Okay, my presentation is about my works. I will start talking about my robots, then about my patents, then about participating in industrial robotics, software works community, and finally my position. I will start with my first robot called Kian Ford in 2003. I use a 1 DC motor for move ahead, 2 DC motor for displacement, as you can see in this part of the video. Other characteristic is that I use a several motor. I use a 10 DC motor. The height is 1.2 meters. The weight is 7 kilograms. The structure is the main is wood and cardboard. You will see how the robot move and use a synchronized elbows with 1 DC motor and other 1 DC motor for open and close synchronized scissors. Why is important this my first robot? Because I developed this when I was 15 years old. Okay, it is my auto robot called Asimov in a pig in 2015. The characteristic of this robot is a reception robot. This reception robot has a weight of 70 kilograms, the height is 1.70 meters, and the structure principle is for aluminum. You will see I use an Arduino and 2DC motor for the movement and 4 servo motors for move the head. You will see how move the arm. I use the servo too with arms. And the rotation is like the robot say no with this set C rotation, and the rotation head in X axis is like say yes the robot. Okay, you will see how rotate the robot and move in the place. I use a app application. I use a Bluetooth communication, and when I hold the button, for example, for move the head, you will see how the robot move his head. Other characteristic is the robot can talk. For this characteristic, I use a speech recognition, pre-programming response with movement and text-to-speech. Okay, you heard the voice of the robot Asimov. When I ask, the robot Asimov responds. This is the technical diagram I use when I mention a mobile application, Bluetooth, controller Arduino for control the 2DC motor and the servo motor for the arms and move the head, and the mobile application command by touch screen button for move the arm displacement, move the head, and command by speech recognition, who I mentioned before. In this case, is for dance. Is other characteristic. I mix the all movement with some music for the robot dance and pre-programming response. My participation percent is mechanical 60%, control programming 80%, and mobile APP programming 100%. It is my auto robot called Heart in 2019. It is a tourist robot. The weight is 23 kilograms, the height is 1 meter. I use usually the structure aluminum. This robot has 4 options for select into screen. Imagine a tourist can save their things in this safe locker, and maybe if it needs some information, only need to push one of these 4 options. For the robot, give this all information. This is a diagram. In the same way, I use a mobile application, Bluetooth controller is the Arduino for controlling the displacement, but in this case, I use a Raspberry Pi for operative system in Android for speech message. Use command by touch screen button for option to speech. My participation percent, mechanical 85%, controller programming 100%, mobile application programming 95%. With this robot, I have some students for participate in the construction on the making this robot. And this other robot was making at the same time. The robot is a poly robot. The weight is 22 kilograms. The height is near to 1 meter, and the structure the same aluminum and plastic. The device sends an alert to the robot to an alteration of the carrier pulse. This device in the arm, and you will see the sensor. The other characteristic is about transmission, video transmission and position from the robot to the user. You will see in the application how to transmit the video. You push the button for send alert and to on or off the light of the robot. It is the Police robot Calypton robot. About technical characteristics, in the same way, a Qt Inventor for the application, controller Arduino, for movement the robot, but in this case I use a camera and GPS for transmission to the mobile application by TCP and IP. And in the command by touch screen button, press displacement to on off the lights and to on off the sound alarm. You will see in this part of the video a motor torque test and extra weight on 5 kilograms. It is my I usually use test if the robot has the characteristic for all the things that we will have. It is my auto robot called WeRobot 2020. I use Intel NUC in this case for operation system in Windows. The height near to the 2 meter, the weight 45 kilograms, and the structure is stainless steel. I control it with application. I use a Google Cloud natural language processing for the robot response. You will see.
Buscar la fanpage de Robotics, la page podrás enterarte de mis novedades.
It is the servo motor that I adapt about a DC motor. So I made 6 DC motor convert to the servo motor, 3 for the right arm and 3 for the left arm. It is the test with right arm using my servo motor. It is the test with the left arm. In the same way, for this case, I use communication RS485 because I need to communicate with each servo motor sending the command. Okay, this is my robot WeRobot. You will see the technical diagram. I will explain you a little. I use, how I mentioned, a Google Cloud natural language processing when I acquire some word, the Google, the NLP, the Google Cloud ask in the database and give me a response. This web server is in my Intel NUC, and then with this response, use a third-party voice AP for text display and the principal, the speaker. Of course, the input is a microphone or input text with touch screen using WebKit speech recognition. Usually use in this part the WebKit speech for Google Chrome or maybe for Firefox AP. Okay, in the other part, I use the mobile application for controller with Arduino. I use the communication with I mentioned before, the RS485 for controller, the 2DC motor, the 3 servo motor for the right arm, and the 3 servo motor for the left arm. My participation in this case, mechanical 95%, controller programming, and mobile application 100%. This is my auto robot called Haika 2021. It is a delivery robot. You will see the wheels. Okay, it is a rocker bogie suspension, allow climbing over uneven terrain. Other characteristic of the robot is about the how open and close the door using a remote control by Bluetooth. This is the application that I developed for Bluetooth communication when I control the robot. Other characteristic is that the coupling strap between box and mobile robotic chassis. Because if you need to transport the robot, I need this characteristic, the control and power plugging connector between box and the robot chassis. It becomes more easy for transport all the robot into part. This is the diagram, technical diagram. I use a mobile application, control Arduino, but the difference is that I have a 2 version. The one version you watched before in the video, but the second version I use a relay and ESC. It is a cheap way that I found for controller a brush motor. You will see in this video. the test. Using this chip controller, we relay an ESC and how the robot moves. About mechanical control, programming, and mobile application is 100% my participation. Okay, I would like to talk about my degree thesis in this project in 2012. Obviously, I use a cinematic, reverse cinematic, and inverse cinematic. It is a simulation of a part selection process from backpropagation and scaling. The scaling, I use the software of Labio. In this case, I use a Microsoft Robotics. The input value are length, width, height, and color for the backpropagation. Programming in C#. This is scaling. I use a virtual camera for embed in the software of Labio. You can see now in the video. This part is the scaling when you will see in real time the training of the neural network. When it gets the 100%, in the light turn green and the training is ready. In this case, the neural network was training for arrange the piece taking the color. First, the first column is with green piece, then is the second column is with blue, and third is with red. I can training the neural network in different ways. Okay, I will talking about my master thesis. It's very simple presentation for try to understand. First, the TO robot was made by the UC3M. TO didn't have a teach data for kick test, so this is the reason for my master thesis. The application for kick test of TO. I can send commands programming. For this, I use a JAR protocol, allow communication to that robot in ROS language, APP in Java. I connect with TO simulation in the part in the top part, and connect with the real TO with the table that I have, and move maybe the right arm. So it was practical because it's like a standard, but with a mobile application for send commands. You don't need to start maybe a virtual machine or your Ubuntu. Only you connect directly with the CPU of the robot. About my patents, I will talk first about the browser in 2016. Can you imagine a way in which blind, deaf, disabled, or non-disabled people receive information in the same way without distinction? Okay, it is about my project, how it works. Okay, first, the message is encoded in audio format to be transmitted from any mobile device. Then coding based on multi-frequency pulse was used. For example, we will transmit a mathematical question. It sounds like this. Okay, this sound is multi-frequency that you use in your mobile. In this part is to translate signal into electrical pulse. The electrical pulse are distributed in a matrix that can be learned by the user through the skin. I thought that maybe can be a good device for all the people can receive the same information in the same way without distinction, only using the skin. Okay, in this part I have maybe a mobile, tablet, laptop, PC, etc. Maybe you will see you are watching a movie, but imagine in your movie you have a codification. You have a output audio with this DTMF codification, and you send this audio codification to the decode DTMF, and the controller Arduino transform this analog signal, the decoded DTMF, to the digital signal transmitted by Bluetooth. And then you have a receiver to control Arduino for show in a display for you see is the what is say with letter for so only for contrast. But the real important is when the Arduino controller transform the signal to the electrical pulse and send it to the matrix of electrode. So maybe you are in your car and you receive with a device the news, for example, or maybe you are sit in your home and you are learning a new language only with electrical pulse in your skin. Okay, my participation It was a mechanical control programming and mobile app programming 100%. I had this patent in 2016. My other patent is about the smart card reader in 2018. Uh, exists a smart card? Yes, exists in the world, but the main characteristic of my patent is about the relate to the electronic distribution and the case designs. This characteristic is more compact, and you put the smart card in the behind, in the back part of the smart card reader. Other smart card, you put the card but in the left or in the right side. But it is a problem when you want to use the other ports in your laptop, in your PC. It is my third patent about RUB. It is a robot ultraviolet. Ultraviolet. I am ultraviolet association member. This robot has a manual and automatic mode, writing or disinfection, a 1.5 meter by 53 seconds. I use a UVC Philips lamps of 90 centimeters. The turning system to avoid shadows. This is the main characteristic. You will see I made it is a printer 3D and designed with Inventor. The lifting system to disinfect upper and lower areas is very important for try to give a good disinfection. This is the system for the lifting. Okay, this is my robot and use of ultrasonic sensor to avoid obstacles. It is a technical diagram. In the same way, on my other project, I use a mobile application for test for my Bluetooth communication, controller, Arduino, my input ultrasonic sensor, motor drive, wire to DC motor for displacement, but I use in this case a communication RS485 because this communication help when it's a long cable for you have a good transmission. So the control one transmits to the control 2 other Arduino for the motor drive, for example, for move the CX rotation or motor for lifting. And of course, I have a limit switch for this condition. And the command by touch screen button, a manual mode and automatic mode, and test obviously for turn on the lights UVC and turn off the lights. It's important to know that the UVC lights is dangerous for people, so you need to be careful in this way when you make some experiment with this lamp. About industrial robotics, I can mention I had expertise programming ABB. You will see in this software, it is a little complex simulation using a robot studio. I really like it because when I publish in this video on YouTube, ABB Robotics mentioned that they really shared my video in their Facebook fan page. So I like this comment. You will find this in my video in YouTube. The other thing I have a certification in programming in KUKA. I study in KUKA College. You will see my two certification, and this is my implementation, like engineering. This robot is I am proud about this robot with implementation and a welding robot in a metalworking industry. The robot programming and engineering by my company N Robotics. It was the last year. My other words, a little maybe a test of gesture control using my controller. For you can see, if I move the hand, I take the sensor and move the robot arm. This other project for me is important because it's a multi-drive low cost with A2212 Bristling motor because I get a reduction 110 to 1. It is for me it's a good reduction. With I use a printer 3D. I use a material that is very cheap. So my own design is a variant of the Simon Merritt in 2016 design. This design you will see in the video use a closed timing belt The difference with my design is I put in this design a brushless motor for make a servo motor with harmonic drive. I like how you can see this movement inside the servo motor with harmonic drive. Okay, this is my other project about the virtual environment. I use 3 years. This work maybe took me 4 months, 5 months. So it is I did my basic effort in this virtual environment. I use a 3 years. I use a WebGL. WebGL is when you put maybe some objects or import some objects in 3D in this space. And CSS3D is when you put maybe a HTML, a web page, or maybe you put inside a video transmission, like Facebook transmission, or maybe YouTube Live, or in this case, maybe a Zoom or a Jitsi. So using the server side and Node.js, I will show you an example. For example, this is my virtual world. I can move with a keyboard, and I can move with a bolt that you will see. The principal characteristic, well, I can simulate physics. Other characteristic, and with the camera, and if I click in the other person, it's a multiplier, like a game. I can write something like this, and you will see the message in here part. In his part, you will see I use the refraction. You will see the water, and the sea is so realistic because it is a 3D motor graphic 3ds. I inside this virtual world, I put some presentation, for example, about some parts of my events, robotics, that I will mention after, and a YouTube video that it is the part of the CC3D, this YouTube video. And you can interact with this video, of course. You can play or you can stop the video. Okay, return to the presentation. I would like to mention about my communities. I have my first community is called Da Vinci Tesla. I am the creator of this community with 70 thousand of members. The objective is to share information about science, stage, awareness of our resource and animals. And my other community is about robotics. Robotics International Community with 6,000 members approximately. The object is to reduce the robot gap in Latin America through international network. I am creator of this international robotics community. I am here in this picture because it is anniversary of the robotics group of the National University of Callao, because I am the founder of the robotics group of the National University of Callao in 2008. From 2008 and 2021 exist 14 chairs. It is my line following robot, Scobot, in my university time. My position, I am a general manager of my little company about industrial robotics. It is my other project, Robotics Lab, because I want to consolidate the robotics research in Peru. And I am developed this idea with Rolando Cruzado. He's a co-founder of Robotics Lab. He is a master in innovation in UK and a celebration manager in CXL in USA. We're planned for launch an acceleration program in Latam for 2022. We have a strong partner because we have IRA, International Alliance of Robotics Association, and Silicon Valley Robotics Industry Association supporting innovation and commercialization of robotics technology. The idea is have several startups, and with these startups get a good presentation, they can enter to the circuit launch in Silicon Valley Robotics and get some benefits with IRA. From 2015, 2021, I was a teacher. I teacher in 6 university and 1 institute, in laboratory, like a laboratory system in 1 university. System engineering, I teach in 12 subjects, electronic and mechatronic engineering 4 subjects, industrial engineering 2 subjects, and telematics 4 subjects. I was a thesis jury 3 times and thesis supervisor 1 time for undergraduate students. Actually, I am a mentor of Acceleration Founder Institute, and actually, I am a chair IEEE RAS in Peru, 2021 to 2022. I will show you. You will see in the web page of the IEEE RAS that I am. This is my team. We are working effort for give help and information about the student about robotics. I create the category in this event Intercom 2021. Intercom is a great event about IEEE in Peru. This event, I create a mini humanoid robot contest 6 to 8 in August. I called for 200 electronic and mechatronic engineering students from Peru were obtained for type of mini humanoid. The idea is get a best type of mini humanoid developed, and this become an open source project for get a lot of people participate, use this information and improve the project. So I supervise for types of humanoid robot, the best humanoid robot low-cost project from April to May, and we present for paper of which 2 were accepted at Intercom. Remember, Intercom is event at IEEE with indexing in Scopus. I am proud about this because I get 25 teams for this mini humanoid robot contest. So the participant is 87. 87 participants. For me, is a good number. Okay, you will see now the 2 principal mini humanoid low-cost projects. I am proud, of course, of this robot. The height is 28 centimeters, the material MDF, and number of servos is 16. The weight is 312 grams. It is the other robot. This robot not working, but is impressive. It's a nice robot with 20 servos, and the height is 29.2 centimeters. The material is only cardboard. So it is open source. We post all the diagrams for all the people can replicate both projects. My participation about mechanicals is 40%. The controller programming is 70%. How works? You send by computer, connect by USB, send some character for the Arduino. You can move forward, move backward, or move the arms. I use a multi-servo drivers, the PC96A5 for controlling the servo motor. It is a very cheap servo motor that you can find in some place. The SG90 and or the MG90. I participate with the mechanical consideration using servos. I teach about some students with the calibration of servo motor using a sagittal, transversal, and frontal plane, or the programming movement like stop motion with Arduino. When I mention like stop motion, it's about the movement pattern generation is manual. Each movement is manual. The programming, and the command movement is with serial input chart. If you send, for example, the A, it significates move forward. The B is move backward, etc. Okay, thanks. It is my presentation. I will waiting. Maybe if you have some question, I appreciate your attention. Thank you very much.